Okay.
All right.
All right. Come on up.
Okay.
We'll get started, everyone. Dr. Gary Locklear is professor and chair of computer science at Concordia, Wisconsin, where he has served for 30 years. He and Dr. Joel Heck are founding members of the Concordia University System Society of Creation. He is a technical advisor for the Lutheran Science Institute and serves on the board of directors for the Creation Research Society, the oldest international scientific society devoted to research in the creation model of origins. He and his wife, Karen, have 5 children, all of whom are Concordia, Wisconsin graduates. They have been blessed with 8 grandchildren and enjoy living on a small hobby farm, caring for rescue animals and viewing God's creation. Dr. Locklear.
Great. Thank you very much. That is absolutely the best introduction I've had today. I do appreciate that. Oh, wait, I wrote that. Okay, good enough. Thank you so much for being here. I definitely appreciate this conference. I appreciate UPCO who put things together. I appreciate the Bioethics, I'm going to say Bioethics Institute. Help me, Dr. Voss. The current correct name is?
Center.
The Concordia Center for Bioethics for helping to sponsor this. The concept of classical education is near and dear to me, as I'm sure it is to a number of you also. So what are we going to talk about over the next 4 hours? We're going to be talking about, over the next 50 minutes. We're going to be talking about computer science in classical education. For many people, this seems to be an oxymoron. Computer science, classical, a different way of thinking or doing computer science. That's what I'd like to investigate with you. Usually when folks hear the concept of classical education, their response is, classical education? What are you guys doing? Are you sitting around reading Latin and parsing sentences? That's crazy. You need to get a practical education in a career field that will get you a good job. Well, as a matter of fact, I think that computer science is a great way to bridge and connect both of these ideas. The ideas of a good classical education, and then also the outgrowth of something practical too. So what is classical education? You know why this doesn't work? Because you don't know what that is. That's a Nintendo Entertainment System controller. So when we talk about classical education, we're obviously talking about things, that's not what we're talking about with classical training. To understand computer science and classical education, we first of all need to understand what is computer science. Computer science may not be what you think it is. If you take a computer science course with us here, and we're blessed to have 5 really good people teaching computer science, and Dr. Angus Manouge is one of them, what you'll hear from us is the following. Computer science is not the study of computers. Computer science is not the study of technology. Let's put it this way. If you asked an astronomer, what do you do all day? Would you assume that what astronomers do all day is they study telescopes? Yeah, sitting here grinding a lens and polishing my telescope. Or if you asked a biologist, what do you do all day? Would you expect them to reply, well, I study my microscope? Of course not. The telescope for an astronomer, the microscope for a biologist, those are tools of the trade. They use those tools to help them investigate something different. It's the same with computer science. We don't investigate, we don't learn about, we don't study computers. Instead, what computer science is the study of problem solving. Fundamentally, computer scientists, information technologists, we're concerned about investigating problems, how people think about solving problems, and then quantifying that so precisely that we can get a tool, a technological tool, a computer, to actually carry out and solve those problems. For example, maybe something sort of middle of the road here. Would you expect a musician to be able to build their own musical instrument? Do you suppose that world-class pianists, could they construct a grand piano from scratch? No, probably not. In the same way, computer scientists, we're really not that worried about creating computers. Now, many of us could do that, but there's something much more interesting. To a pianist, the type of string that's strung there, whether it's catgut or an artificial thing, is not nearly as interesting as musical composition and theory and keyboarding. And same with us as computer scientists. We're much more interested in solving problems. See, technology is a tool. It's a tool that's used by everyone today. You'd probably laugh out loud if I asked, how many people have used a computer today? Thanks for laughing out loud. Yeah, probably the first thing you did when you woke up. Or maybe your phone even woke you up. Technology is just a tool. It's used by everyone, for everyone, and that's what we as computer scientists investigate. Now, if you think about the universality of technology, that's one key to see that computer science is an integrative, multidiscipline field. One theme you'll hear me say a couple times is computer science is not just computer science. Computer science encompasses many different subjects, can I even use that term? Many different areas of knowledge. We, as computer scientists, solve other people's problems. Computer scientists do not sit in their windowless room and dream up funny things that they can just do for themselves. We solve other people's problems. As a matter of fact, everybody in here has used the fruits of that. All the apps on your mobile device. Well, okay, quite frankly, I don't want to take credit for many of those things because a lot of them are just junk. But you're reaping the fruits of that in many different areas. You're not computer scientists necessarily, but you can see how understanding other areas and ideas is very helpful to us. As a computer scientist, and what we try to get across to our students here is, to be a good computer scientist, you have to understand the problem domain. What is that person's problem, and how do we solve it? For example, if we're going to create an application that deals with accounts payable, and there are lots of applications with accounts payable, you know what? Computer scientists would have to know something about accounting. You can't create an app that's going to solve an accounting problem without knowing something about accounting. So we solve problems for other people. One of the recurring themes you're going to hear is computer science is really problem solving. Reminds me of my friends Zeb and Martha. One day Martha took off for work early and Zeb was still at home. You need some context for this. Today is not very warm, is it? You remember the polar vortex from a couple months ago and maybe even a couple weeks ago? Yeah. So this is one of those polar vortex days. So Zeb's at home and he sends a text to Martha. He says, "Windows frozen." And Martha texts back, "Pour hot water on them." And then, yeah, as you know, a few minutes later she gets a text, "Computer's really screwed up now." That was a joke. It was a joke. Let's try another one. When I started off here today, I was logging into the system because Dr. Voss asked me to record it. And you know how this works. Oftentimes you log into a system and it says you need to change your password. So I gave it what I thought was a great password. My password was 14 days. And then the system responded, "Password rejected." Why? Too weak. 14. Oh, good. Thanks for laughing. By the way, remember that and come to class because oftentimes my students are not doing that for me. So here's my thesis. If computer science is used in classical education, I believe that computer science is actually a liberal art. Now, early in this conference, you heard from Dr. Veith and Drs. Harries and Mobley about this idea that there are 3 liberal arts at the foundation, the Trivium, 4 liberal arts that expand upon that, the Quadrivium. These are not separate individual subjects, but they're ways of thinking, learning, and knowing. Computer science is a liberal art. Let me give you an example. An outgrowth of computer science that you probably recognize the term, perhaps, analytics. If not, you've certainly encountered it. If you watch sports or listen to sports, you know that they're always saying, well, there's a 37% chance here that they're going to run this play, or there's a 53% chance that here on 3rd down they can make it given this particular alignment, and many similar kinds of things. If you've ever done anything online, has anybody, you know these ads that follow us around, right? Whoa, how did it know that? Or you go to a shopping site like Amazon or eBay. Hey, how come they're bringing this recommendation up? That actually sounds pretty interesting to me. How do they do that stuff? The answer is analytics. Analytics is an application of computer science, but analytics is the analysis, the explanation, and the communication of information. Now think about that. We use computers in that environment. We use it for all 3 to analyze, to explain, and I'm using it right now to communicate. But if you think about analytics, it's much more than just a computer. Computer science and analytics, I'll just read this little quote to you. Analytics is an encompassing and multi-dimensional field that uses mathematics, statistics, predictive modeling, operations research, machine learning, artificial intelligence, this goes on and on and on, to find meaningful patterns in data. Yeah, computer scientists, we do analytics, but this is just one of a number of great examples of the liberal arts nature of computer science. Did you hear some of those other things in there? I mean, think about machine learning. That actually relates to human beings, biology, psychology, physiology. There was mathematics and statistics there. There is operations research. There was communication. If you're going to do analytics as a computer scientist, you have to understand much more than just computers or computer science. Analytics reaches into so many other fields, including trying to influence human behavior. Hey, let's see, can Jeff Bezos convince you to buy this specific thing? So what's the point? Computer science is not some little pigeonhole discipline all by itself. It interacts with almost every other discipline that you can think of. Let me make a stronger case for the classical education of computer science. How can we think of computer science in a classical sense? One aspect of classical education that we saw before in this conference, and many of you already know, is the idea of the trivium. Now, the trivium is interesting because it can both be a subject and a pedagogy. For example, as a subject, think about language. Well, to understand language, you got to know the grammar. Here are the basic rules of it. And then once you know the basic rules of grammar of a language, now you can start putting things together. Oh, the teacher showed you a sentence, now you make your own sentence. And then ultimately this grows and flourishes into the rhetoric I'm going to put my own ideas together and share them with you in a discussion. This is a great way to learn any subject. So not only just thinking about language this way, but this is how we teach computer science. I appreciated what Dr. V said on the first day. He said, folks who are concerned and care about education likely do classical education without even knowing it. When I first began teaching, which was a few years ago, I didn't know much about the Trivium. I'd heard some things of classical education. But in thinking deeply about how I wanted to approach, I came up with these three ideas. I say, to understand computer science, you got to know theory, then you have to practice it, and then you have to apply it. Well, sounds really good, right? But all that is the Trivium. The idea of theory is just the basic concepts. If you want to learn computer science, you have to know a number of basic concepts. Everything from binary form up through the syntax and semantics of a programming language. Here are the basic chunks. You learn that. The next phase is, okay, practice with these things. Let's say we're going to do a programming language. So I'm going to share with you some fundamental ideas of the Python programming language. And now I'm going to give you some very specific tasks. Take this and do this. Write a little program that prints out the first 10 prime numbers. And you struggle with that and you find, oh yeah, good. Then do another one to learn something else. That's the logic stage, is just the practice stage. And then ultimately, guess what? Yes, we get to do something interesting. We turn you loose. Okay, do this project. Now your task, budding programmer, is to create an app that's going to allow a person to do the following. Yeah, it's scary. But to do that, the rhetoric stage, you've got this grammar foundation, you understand how to put things together, things work well. So computer science has a grammar, a logic, and a rhetoric. Every subject has a grammar, a logic, and a rhetoric. So in one sense, we can think about computer science and classical education by teaching computer science in a classical sense. The liberal arts, though, are really a way to connect many different disciplines and, if you will, spheres of learning together. It's a way to understand many subjects in order to ultimately create a system. Computer scientists have to understand problem solving and think critically, as we'll talk about in a bit, of course. But really, let's take a specific example, maybe something you work with all the time. Speech recognition. I ask students, do you ever talk to your phone? Sounds funny, right? Nobody uses the phone to make a phone call, right? Just old people like me, okay? I mean, you would never make a phone call. But I'm assuming that many of you actually speak to your phone and use the virtual digital assistant. You use Siri, you use Google, you use Cortana, or whatever it might be. Well, think about the creation of speech recognition. In order to create an effective speech recognition system, computer scientists just didn't, 1011. Speech recognition is an outgrowth of artificial intelligence. And artificial intelligence means that, first of all, we have to understand human beings. We have to understand the nature of speech, which is a biological function. We have to understand that. Secondly, we have to understand the nuances involved in the psychology and the physiology of formulating sentences. I don't know about you, but my wife and I always complain about this. You say something, I don't know, some of you guys actually text with your thumbs, right? I mean, I don't do that. I just talk to the phone. But the phone never understands what I'm telling it, because there's lots of physiological nuances and things that psychologists and physiologists call what's that called? Defluences? I don't think that's the right term. But that's when you start something and then you stop. What I really mean is, how do I process all that? Right? Yeah. So you have all this stuff from biology. Of course, speech recognition is communication. So you'd have to understand the theoretical aspects of communication. There's some engineering involved. How do I change an analog signal, my voice, into digital bits that the computer can understand? Of course, there's English, or whatever language it is, and there's some mathematics, there's some philosophy, there's some logic. To create speech recognition, or really any interesting application in computer science, requires a wealth of knowledge. What I'm going to claim is a liberal arts mindset. So the Trivium, what I always talk about is theory, practice, application, or what we've heard here is grammar, logic, and rhetoric. I almost said rhetoricus. Rhetoric, there, is not only a way of approaching and learning about something, but it's also a way to understand that subject. Now, I would not recommend that computer science be what we use to set the foundational liberal arts. The Trivium, and especially dealing with language, is the way to begin. That's the way classical education begins. Let's think about language, your language, and understand those things. But in classical education, once we have the foundation set, now we can apply them in spheres of knowledge. As you heard from Dr. Veith, the quadrivium was the application, so-called mastering the arts, and those were the mathematical arts. There was arithmetic, there was geometry, there was music, and there was astronomy. If Dr. Stricker were not at this conference, and because he does astronomy, I would like to say, let's get rid of astronomy and replace it with computer science. I think computer science is a better quadrivium subject than astronomy is. Let me read you this little quote. The quadrivium carried with it an idea that foundation should precede specialization. So understand the, should we use the word understand the basics, understand the trivium, before you specialize in any one of these fields. One of the dangers of an increasingly technophilian culture, is that we are inundated by new technology every day. We become enchanted by the end result, a flashy new app, and too quickly forget, or never understood in the first place, the concepts behind it. Computer science allows us to understand the concepts behind all these flashy things that we work with all the time. By the way, the quadrivium, the four classical applications here, all dealt with numbers. And computer science certainly deals with numbers in the concept of multitude, many numbers, and magnitude, the size of those values here. Why would a classical education that includes computer science, why would that be maybe more practically valuable? Here's why. Employers don't want geeks. I rail against the term geek. Originally, the term had a good, positive sense among computer scientists, but today the term geek is applied to those people that can't interact with another person, very socially awkward, but they could talk to a machine in ones and zeros. And we have somehow celebrated that. Oh, that's okay because they can fix a computer and that's great. No, it's not. You know what? Geeks are not employable. A long time ago, a really long time ago, I worked in the computing industry. And at that time, I worked for Hewlett-Packard Corporation, and I interviewed a number of people, and I hired several people. And I appreciated the fact that the company that I worked for, about the time that I got there, decided, we used to only interview, the 3.99s from Stanford and Carnegie Mellon and MIT and those kinds of places. And then the organization, and I saw the fruits of this too, said, that's crazy. We have all these technophobes that can talk to a machine in ones and zeros, but they can't talk to other people. Where's the danger in that? We create tools for other people. As a computer scientist, I need to create apps and systems and tools for other people. If I can't communicate with that other person, if I can't understand what their needs are, if I can't work with them through a problem, I'm really not useful. I love that comment from Dr. Veith on Friday when somebody said something like, well, shouldn't we just be trained to get a job? Dr. Veith, yeah, if you want to be a slave. That was the servile education. Hey, go to computer boot camp, and in 12 weeks you can learn Python programming, and you too can make $50,000 a year. Maybe, but I'm going to tell you what, 3 years from now you're not going to be doing that. Because 3 years from now everything's going to change. And the only way you can adapt is if you have a broad, basic education understanding these things. Let me give you, so the moral of the story is, computer science in a classical sense educates free people. People who are liberally educated, who can not only do a job or a task well today, but can do it in different contexts and can do it 10 years from now too. Let me try to prove this to you. We'll come to this person in just a minute. But this is something that I'll ask when folks come to me and say, you know what, why do I have to learn about English or literature or history or bioethics? I just want to be a computer scientist. I just want to learn about programming types of things. I do get this a lot. I want to be a game programmer. Fine. You can't start there. Well, why do I have to know? Here's my question to you. Do you suppose that this is ancient, so let's stay a little more modern. Do you suppose the people who created the modern discipline of computer science in the second half of the 20th century, do you suppose they had degrees in computer science? Do you suppose that the first college professor of computer science had a PhD in computer science? No. No, they created this discipline. The whole historical development of computer science is people who did not have degrees in computer science. I point to the origins of computer science to this person here. This is Wilhelm Schickard. Wilhelm Schickard, he lived in the first part of the 17th century. That's 400 years ago. Wilhelm Schickard was a Lutheran pastor, and a Lutheran professor at the University of Tübingen in Germany. What Schickard did is what computer scientists historically do and what we should be doing today, the classical method. Schickard thought about ideas that today in computer science we give fancy names like algorithm and abstraction and automation, etc. Here's the backstory. One of Schickard, oh, by the way, this thing here, that's so cool. I teach in that. If you give me one of those, that is, I love that little frilly thing. I don't even know what to call that.
Yeah, I often wonder how they developed that. There must have been a reason for it.
Yeah, it must have hid something. Maybe he had things on his neck or something.
Armor.
Yeah, exactly. You got to watch out. Students come up behind you. That could well be, right? It'd be pretty drafty then. Wilhelm Schickard, the context was, his friend was the Lutheran astronomer Johann Kepler. If you know the story, scientists, it was Johann Kepler who really figured out the heliocentric model. You know, Copernicus gets all the press, but he had all the details wrong. So it was Kepler who got all the details right, but that was hard work. So as he's doing his computations, he writes to his friend Chicard, and he says, wow, this is really hard. And Chicard thought to himself, wait, doing arithmetic computations, that's not like brain surgery. Couldn't we create a device, a tool, that would help this process go better? And that's an important point to remember, because Chicard didn't create this thing for himself. He created it for somebody else. We're going to talk about that as vocation, and you're going to see how important that was. So a student called me up and said, hey, the system is telling me to reset my password. I don't know what it is. And I said, it's 1, 2, 3, 4, 5, 6, 7, 8. And he said, is that all caps? Thanks. What's the moral of this story? Computer science is not a new discipline. Believe it or not, the ideas underpinning computer science are 400 years old. Here's the other part of the story that you need. All of these people, I point to Chicard and a co-grandfather as Blaise Pascal. Those two people were committed Christians. Chicard was Lutheran, although Pascal was not very orthodox. If you look a little more recently, if you look to people like Charles Babbage was also a committed Christian. The folks who developed computer science historically and modernly based this upon their Christian worldview. Although George Boole might have been a little unorthodox, he certainly was part of a Christian milieu. He understood that and applied it. So computer science grows out of a Christian worldview perspective. We'll see that in a moment. All right. So what are the benefits and practical aspects of a classical computer science education? The liberal arts are designed to help us think critically. How can you understand something? How can you relate to something unless you have a broad basis of understanding? The purpose of the liberal arts is to help us think critically. And by critically, we can use the transcendentals of true, good, and beautiful. In other words, to think well. There's an interesting story. Oh, it's my own story, so I guess it's not that interesting. But when I first started teaching, I guess one thing that always bothered me as a student is, why do we read textbooks that tell me something about Isaac Newton? Why don't I read Isaac Newton himself? So I've done the same thing in computer science. Now, our discipline is certainly not 2 millennia old, but you can find historic papers. So I would read some historic papers, have my student read some historic papers. And one very important computer scientist is Fred Brooks. And oftentimes Fred Brooks would reference Dorothy Sayers. And I'd read this, and I'd never heard of Dorothy Sayers. And I thought to myself, well, who's this Dorothy Sayers computer science person? I've never heard of her. Some of you know. She's not a computer scientist. So I went to look it up, and I discovered Dorothy Sayers, mid-20th century British author, contemporary of Tolkien and Lewis, kind of like an Inklings group. Maybe she was an associate member. And when I found that out, I said, well, what in the world does a mid-20th century English writer have to do with computer science? You know what? A lot. Dorothy Sayers opened my eyes to an idea that Fred Brooks already knew about, and that is how to create systems well. Yeah, I hadn't thought about this, but when you read it, it makes perfect sense. So I've ripped off her idea, which I don't feel badly about, because first of all, I cite her, but secondly, she ripped it off from the Holy Spirit. This is what Dorothy Sayers says. To think critically means to be creative. But to understand creativity, there are three aspects of the creative process. Now, I say them like this: idea, implementation, interaction. Dorothy Sayers said idea, energy, power, but energy, power don't mean anything to computer scientists. So I always say when you're creating something, there's idea, there's implementation, and then there's interaction. We do this all the time when we create things. Think about writing a paper for that mean Dr. Voss. So in order to write a paper, you come up with, sorry, Kevin, just pick on. So you know you've got to have an idea. And you got to run that through your mind, and you're basing upon the grammar that you learned before, etc. Now, when the paper's due, if you walk up to Dr. Voss and say, okay, I'm done, and he says, where is it? Now, it's not that he doesn't believe you. It's not that he doesn't believe you spent a whole lot of time thinking and ruminating on the process, but he wanted you to implement it. He wanted you to actually write it down. Whip out the word processor, commit your ideas to digital bits. Whew. So you write that paper and you hand it in and then you're all done, right? No. Because the third aspect of creativity is somebody interacting with it. A professional with a lot of experience reads your paper and says, you know, this part is really good. But you know what, this part here, I didn't understand that. That was confusing. You misapplied this. This is a logical fallacy. You misapplied this concept. And then that interaction allows you to grow in your understanding also. Same in computer science. Computer scientists, we have an idea for this wonderful application, the Panopto recording system. And then somebody actually creates it in a programming language, and then people like me actually employ it and interact with it. Idea, implementation, interaction. What's the point? The point is this. Creativity is Trinitarian. What Dorothy Sayers said is, she didn't make up this idea, she got it from the concept of the Trinity. It mirrors the Trinity's creative actions. God the Father had an idea for a physical universe, for a creation. God the Son had the energy to actually implement it, to call it forth via His Word. And we can understand it based upon the power of the interaction of the Holy Spirit in our lives. If you're going to be a creative person, whether that's a computer scientist or anything else, we create in a Trinitarian fashion. That's thinking well, that's thinking critically. Why should we care? Let's say you're not going to be a computer scientist. Okay, why do we care about a classical method of computer science education? Well, because computer science is problem solving. And this could be helpful no matter what your career, job, or vocation might be. Everybody solves problems. Have you noticed that? The reason people will pay you money is if you solve problems for them. Reminds me of the person who called me up and said, there's something wrong with my computer. Some of these keys on my computer are constantly sticking. If you recently, you know that Apple had a release of iOS that did the exact same thing. She says, sometimes the A key doesn't work, but most times the E key will double itself, and sometimes the I key is the A, E, and I key are very sticky. They just don't work well. I was able to diagnose that problem quickly. You have irritable bowel syndrome.
I have it right now because we had a cafeteria.
Ouch, ouch. Yeah, and I should mention, by the way, if you do need to leave, it's okay. Computer science at its heart is problem solving. I shared that with you already. If you know how computer scientists solve problems, I think you'll be a good problem solver in your own field. Think about it. Computers are really complex. Think about an air traffic control system. If you're an old person like myself, you may remember that when you used to fly, you'd get to your destination and the pilot would have to circle a couple times maybe. Today, that never happens. Hardly ever happens unless there's emergency. Why? Because the complex air traffic control system not only makes sure that two planes don't fly into each other, but it also says, okay, plane A, you fly at 447 miles an hour. Plane B, you fly at 451 miles an hour. You're going to get here 3 minutes early, land, get off onto the tarmac, and the other plane lands. And I don't know about you, but that just blows me away. Think about how complex this is. Computer scientists are able to solve complex problems. Understanding computer science means that anybody and everybody will be able to solve complex problems in your own field. If you can apply the techniques that computer scientists understand and use, you're going to be a much better problem solver. One of those techniques is a concept called abstraction. I know when you hear that, you think, people walk out, oh, that was an abstract presentation. Oftentimes people say the word abstract and they mean confusing, cloudy, unclear. Abstract is the exact opposite of that. To abstract something is to simplify it to make it understandable. The job of a computer scientist is to simplify a complex problem such that it's understandable to put into an app, and then simplify the user interface such that a normal person like you and I can actually interact with it. Abstraction is the technique you learn to hide the messy details of the problem. Focus on the foundational important aspects, work on those, and then build up a system. We can apply that anywhere and everywhere. It helps everyone deal with technology. And the basic sense of a computer system is we, computer scientists, spend a lot of time abstracting or hiding the gory details of the hardware from you. No one has to have a PhD in computer science to use their phone. We've simplified things. You don't have to talk in binary, right? Good thing. We've simplified it to make the presentation straightforward. I'll give you one final example of that. Maybe a non-computer one might be helpful. Think about anti-lock brakes. If you're driving a car built since about 1985, you probably have anti-lock brake systems on it. When I was a little boy in driver's ed, they had to teach you a technique called pumping the brakes, such that you didn't skid. You start skid, like, oh, pump the brakes, pump the brakes. Today, the ABS system does that for you. So in driver's ed, they teach you this: stomp and steer. You want to stop the car? Press that brake pedal as hard as possible, and you'll stop the car. Here's the problem. People don't understand the fundamental concept that the ABS system is going to, quote, pump the brakes, end quote, for you. You know what survey says? Most people don't slam the brakes on all the time, right? The first time you encounter a panic stop situation, survey shows that when people for the first time slam on their brakes, do you know what the brake pedal does when you press it really hard?
Back at you.
Yeah, it kicks back at you.
It's scary.
It is scary.
Mm-hmm.
And do you know what people do?
They
take their foot off the brake. What happened here? Guess what? If you take your foot off the brake, is the car going to stop?
No.
No, well, because unless you have a 2019 with adaptive braking, but I don't have any of that stuff. No. So sometimes people misunderstand what I'm saying when I say understand computer science concepts. I'm not talking about physics of electrons. I'm talking about the idea of the system will pump the brakes, so what you need to do is stomp on the brakes as hard as you can. Understanding that concept, I think, would be really helpful.
Sounds like we had a similar problem now with the Boeing 737.
Yeah, exactly.
Very same thing.
Yeah, that's a great point. And if you think about the 737 MAX, I mean, it's a software issue. The complexity of software and not being able to think through all these things is tough. Computer science concepts, but not specifics, I think would help. Oh, speaking of cars, you've heard about Apple coming out with the iCar, right? They just have one little problem. That's trying to install Windows. Apple, Windows. Ouch. The goal of a liberal arts education, the goal of classical education, I think as you've heard through this conference and probably know, is to equip free citizens who can love and serve their neighbor. The goal of classical liberal arts education, especially in a Christian mindset, is to equip free citizens who are able to love and serve their neighbor in their chosen vocation. I'm so happy to have Dr. Veith at this conference because I use his book, God at Work, Your Vocations in All of Life, in my computer science courses, showing students that, first of all, we all have multiple vocations. But secondly, when it comes to your career as a computer scientist, that is also a vocation. We can be God's mass serving other people. We do that by creating good tools and good applications. And I'm sorry to say that not every piece of technology is good. But we, again, solve problems for other people. We don't sit around and think about, oh, let's dream up some funny thing that I could do and win a Nobel Prize for. We look at other people's problems, and we serve our neighbor by creating effective systems that help them solve their problems. That's vocation. I think Luther, of course, famously said, it's not just the clergy, it's not just priests or pastors or nuns that have a vocation. All Christians do, including the milkmaid. Well, I think today Luther's saying including the computer scientist. Because our job, if we understand it correctly, is to serve our user with empathy and understanding of the user's needs. So I think one way that computer science can be very beneficial is with the concept of vocation. I also believe that computer science is a great vehicle to integrate a Christian worldview. A Christian worldview really infuses and energizes computer science. Some of you may know the name John Warwick Montgomery. He's written an article about the Christian roots of computer science, something that I've investigated for a long time also. Both he and I would tell you the foundations of computer science are really built on some Christian concepts, some ideas, especially the transcendentals, the idea of truth and beauty and goodness. I share with my students, when you create a tool, when you create an app for somebody, you need to think about truth, beauty, goodness. The truth one is obvious. Does it work? I'm creating an app to add numbers. Sounds funny. It's actually a semester-long project for juniors. It's not as easy as you think. We're creating an app to solve numbers. It takes about half a semester to get it accurate, just to correctly add numbers. Well, that's truth. We ain't there yet. Secondly, it has to be beautiful. For a computer scientist, beautiful in two ways. Number one, the structure of the code needs to be understandable to not only me as the developer, but to other computer scientists who will maintain it. So that's the internal beauty of it. Secondly, what we call the UX, the user experience, has to be meaningful. People have to enjoy it. We actually use those terms. Are people excited about using this thing? That's the beauty. The third aspect, goodness. An example of the goodness aspect is this. I can create an app that will accurately add numbers. 1.739 plus 2E5. What happens if rather than giving this app a number, I inadvertently give it, well, I know I put a letter in there. That's because it was hexadecimal. So ignore what I just said. 1.93 plus 3.07. Great, it adds that, fine. What if instead of typing that, I type in 1.37 plus A? Many apps are going to drop dead. Has that ever happened to you? You type an error. Ah, what's the error? That's not a good app. Good apps foresee. They say, what might go wrong? How can I either prevent that from happening, or if it does happen, how can I alert the user such that we can gracefully recover from it? So the ideas of truth and beauty and goodness flow from a Christian worldview perspective. That's Paul in Philippians 4. Exactly. But most importantly, computer science really flows from this unity provided by Christ the Creator. I love that slide Dr. Veith had, putting all the Trivium, Quadrivium together, showing how theology is indeed the queen of the sciences, meaning everything else is understood and infused by the idea of Christ as creator. Computer scientists, we are sub-creators. That's the word Tolkien used. Where did he get that from? God's the creator. I can create a fantasy world. We create virtual worlds, but we only do so well when we think about this in a Christian worldview context. Understanding computer science is important for everyone, because that will mean you're neither a slave to the technology, nor are you at the mercy of the technological elite. If you just know the skills, you're a slave. If you know the concepts, you can deal with the system, you can work with the system, you can change the system. It's hard to imagine any career, job, or task today that doesn't require the use of a computer system. Can you think of some future job that you might have where you wouldn't be using a computer? Well, that's really hard. Understanding computer science is valuable for everyone and anyone. Everybody needs to know some stuff about this, but not just the outward skills. That's the slavery part of it. That's the technical training. That's the boot camp type of thing. Understanding computer science in a liberal arts context, that's what gives you freedom. And if Chuck Norris thinks that computer science is good, you know it's good. I would say understanding computer science is mandatory for a free citizen to be truly educated. All vocations can benefit from the use of technology, which allows problems to be efficiently solved. The technology we all use every day, all the time, is based upon computer science. Computer science is both a set of knowledge and a way of learning and seeing, especially in a liberal arts classical view. Basically, computer science is a mindset, a way of solving problems. It's a liberal arts way of looking at solving problems well. One other thing I'll leave you with, and that is I'm making a plug. This is sort of nepotism. We should keep it in the family. This is my daughter. She has a book on apologetics called Called to Defend. And in this book, she actually talks about using computer science as an apologetic. If you're a Christian and want to discuss Christianity with non-Christians, well, what are you going to talk about? Actually, you could talk about computer science and see how computer science will automatically point back to the Creator. If you're interested, I've got a number of little brochures. These are free. Be sure to take one. If you're not, that's okay. I'll just take your name down that you didn't take one. But it's really interesting. She originally wrote this with middle school students in mind, but there's a great review in here by Dr. Angus Manuse. Some of you may have heard of him, that says, this is for everybody. Everybody can benefit from these things. I know I didn't leave much time. That was sort of planned on purpose. But if you have any questions, I could entertain a few. But I frankly would rather not. That's a classic teacher trick they teach you, 30 seconds before the end of the okay, any questions? Oh, yeah, let's talk about the meaning of life now. Nope, let's get out of here. Folks, thank you so much. I appreciated you being here. It would have been kind of silly if you walked by because there were nobody here. I still would have given the presentation. But it's much better to have that interaction with other human beings. So thanks for being here and part of this conference. Thank you.
So you're still taking questions?